Okay, here's an example of how you might use some of your parallel line theorems in a proof, because if you notice in this proof, we are given information about lines being parallel. So if we set up our proof, the first part is what I call the geometric brainstorming part of our proof. And as soon as I write down my given information, I'm going to have to be thinking, what does it mean if lines are parallel? What does that tell me? And that's the brainstorming I'm going to do. Now, you actually should have a lot of things that are coming to your mind right now, because we've talked about all kinds of angle pairs, and you now have you have a postulate and several theorems that tell you information about angle pairs when lines are parallel. So we're going to have to be sort of specific in what we're saying and not just start writing everything down, because you guys are getting to the point that you're too smart and you're going to list out a whole bunch of things that are true but maybe not necessarily get anywhere. So typo there, ignore that. We've got angle 5 we're going to try to show is congruent to angle 11. I'm going to start with angle 5 and find that. And then I'm going to find angle 11 over here. And the first thing I'm going to ask myself is that an angle pair? Because if that's an angle pair, I can say they're congruent by whatever angle pair theorem I have. But 5 and 11 are not an angle pair because I don't have a common transversal. So going back to chapter 1, not an angle pair, and therefore I'm going to have to do some work to get there. So I'm going to start with, can I say angle 5 is congruent to any other angle in the entire picture? Because it is an angle pair with quite a few angles. So you might have one of many different options coming to your mind right now. And there is no right or wrong. So I'm going to throw something out there, but feel free to do whatever you want if you're seeing something different. I a lot of times see corresponding angles. Maybe you're seeing vertical angles. I'm looking right now at angle 5 and angle 13. That's just what's jumping out at me, and 5 and 13 are a corresponding angle pair. Because I know corresponding angles are congruent, I can state that angle 5 is congruent to angle 13. And that's my corresponding angles postulate that tells me that, number 10 on your blue sheet, your theorem sheet. No, I'm sorry. It's number 10 on your blue sheet, but it's actually a postulate, and that's why I crossed it off. So it's actually on your green sheet. If you want to write out the statement is saying if lines are parallel, and indeed lines A and B are parallel, we're given that, then corresponding angles are congruent. 5 and 13 is my corresponding angle pair. Now, I need to get 5's congruent to 11. So I have two choices now. I could go to 11 because I haven't said anything about angle 11, and clearly I'm going to have 11 somewhere in my proof. Or I can pick up with angle 13, and I'm going to actually choose that because I don't want to start talking about more angles than I need to. So I'm going to look at angle 13. Is angle 13 actually congruent to 11? If not, is it congruent to something else that might be congruent to 11? So, for instance, I could say angle 13 is congruent to angle 9 because that's another pair of corresponding angles if we're looking at these two. But if I take a look at 5 or 13 and 11, because I don't like to make my proofs longer than I have to, 13 and 11 are what kind of an angle pair? Well, they're across the transversal, and they're both inside between my two lines, C and D. So right now I'm just looking at the bottom half of my picture. And 11 and 13 you should be recognizing as an alternate interior angle pair. So I'm going to say angle 13 is congruent to angle 11. Or you could have said 11 congruent to 13. And this one is my alternate interior angle theorem. I believe that's number 11 on your blue sheet, your theorem page. So this time the hypothesis is up here at the top. It's the if C is parallel to D, then angle 13 is congruent to 11 by my alternate interior angle theorem, because if lines are parallel, alternate interior angles are congruent. And things are falling into place very nicely for me because I want to prove 5 is congruent to 11. So we could do a whole lot more brainstorming here. There's a lot of other things we can say are true, because like I said, you guys are getting really smart now, and you know all kinds of things about angle pairs when you have parallel lines. But remember, I'm trying to prove angle 5 is congruent to angle 11. And if I take a look at my proof, I've got 5 and I've got 11. Can I say they're congruent to each other? And you should be saying yes. What property are you using? Well, 5 is congruent to 13 and 11 is congruent to 13. So that's fitting one of two properties. If you said transitive, you're correct. If you said substitution, either one of those will work. So either my transitive or substitution property would work right there. Okay, that is not by any means the only way to do that proof, so feel free to be creative with it. And when you get to the next one that's very similar to that, the one right below this, try and see if you can give it a go and make something work. Just be careful not to get too many steps, is my caution to you.